So now let's talk about how we can describe the behavior of a function. So in this particular example, we have our function written out here. And we need to describe when it's increasing, decreasing, or constant. Now, a couple things that I want to make note of. The first is we're going to read this from right to left. Now, there's a couple things that I want to make note of. The first is that we're going to read from left to right. That, of course, shouldn't be surprising since that's how we normally read. Now, the second thing is the y value, our output, is going to tell us if we are increasing or decreasing. Okay, so the y value is the output. It's the actual value that we're dealing with. And the input, or the y or the x value, is going to tell us when we're increasing or decreasing. So, armed with all that information, let's go ahead and look at the graph here. Now, when we look at it, let's go ahead and identify the intervals where we're increasing. Well, increasing would, of course, be going up. So we're increasing along this interval until we hit right here. Okay, and that's a point of change. Then we decrease for a little while. So we decrease, 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 decrease until we hit right here. Another critical point of change. Then we start increasing again, and we increase, increase, increase until we hit right here. And then lastly, we are constant for this last portion of the interval here. All right, so we've identified those parts where we're increasing and where we're decreasing. And where we're constant. Now, we use the y values to do that, so now we only want to look at our x values to determine the interval in which we are increasing or decreasing. And I'll do that right there on the x-axis. So we're increasing from the start point here until we reach that first point of change, that first critical point. Then we start decreasing until we hit that next point of change. Then we start increasing again. And then we're constant for a short period till we hit the end. So, well, that looks a lot like a number line, right? It is, in fact, a number line. So let's go ahead and identify those actual critical points. So here I started at -10, then I traveled to -5, then I travel to 2, then I travel to 6, and then I travel until I get to 10. And we just have to then go through and actually formally write these as intervals. So we'll start with the increasing interval. Then we'll move on to the decreasing interval. And lastly, we'll write out our constant interval from 6 to 10. Now, you'll notice that I used parentheses the whole way through here. To be honest, this is something that's always slightly confused me. There's seem to be some debates as to what you should do. But the way I see it is at this point of change right here, you're neither increasing nor decreasing. For that one moment at x equals -5, you're just kind of floating in the air. Imagine it like you were entering space and then coming back down, that moment of weightlessness. So you're not increasing, decreasing, and it's not constant because it's not over an interval. So we're just going to use open parentheses for all of this. And that's pretty much it as far as increasing and decreasing and, well, constant.